Let's start off with the next type of integration, that is of this type wherein you have the integral sign, the 1 in the numerator you have 1 and in the denominator you have a quadratic equation. So this is a quadratic equation, right? It may be you may might be able to factorize it or may not. And or else the question will be of this type. In the numerator you will have 1 and in the denominator you will have square root and then a quadratic. Okay, so let's see how we can solve this. So in this again we'll be actually using the seven formulas which we have discussed in the last lecture, and let's start off with one of the questions to see how we can solve it. So let's say the first question is integral of 1 upon x square plus 4x plus 8. So in this case, we are not focusing on factorizing the quadratic equation. Okay, you might be able to factorize it, and then there is one more method also to solve these type of problems, but that we'll use in the future lectures where we'll do partial, solving integrals using partial fractions. So that is later on. But right now, let's see the other method. So you have 1 upon quadratic. So what I'll do is I'll try to convert this into perfect square. So this is something which you have done in school. You just have to use that method to convert into perfect square. So what is the method? You just have to make sure that the coefficient of x square term is 1, so that is fine, x square. Then the x term, the coefficient is 4, and you will take it with the sign. So this is plus 4 and you will divide by 2. When you divide by 2, so this is 4x, but when you divide by 2, the coefficient you will get 2. And when you get 2, you just have to square that and write it here, right? So what I did is this, I take it here, this is 4, I divided it by 2 and I get 2. Then I square it. When I square it, I get 4. And what I have to do is I have to add 4 and then I have to subtract 4 to balance it out, right? So hope you understood. See, coefficient of x, it's 4, you divide by 2, you get 2. Then next step you square, you square whatever you get 4. You add that term and you subtract that term. The reason we do this is, now see, we can make this a perfect square. This is actually x plus 2 the whole square, and this is 8 minus 4, which is minus, this is plus 4 dx. Now we convert this into a perfect square. So see, what has happened is this is x plus 2 the whole square plus 2 square dx. And now this is a formula. So this is actually the formula which we use in the last lecture, that is integration of 1 upon x square plus a square. So where x is x plus 2 and here for a you have 2, and the formula for this you just have to remember the formulas. So for this the formula was 1 upon a tan inverse x by a plus c, right? So you can just try this and solve this. So let's solve this one. So what you get is, we get is 1 by a, which is 1 by 2 tan inverse x plus 2 by 2 plus c, right? So this was the first question. Let's try the next one. So the next question is integration of 1 upon 2x square plus x minus 1 dx. Now in this case the thing is that the coefficient of x square is not 1. So what I'll do is, to make life easier, I'll take this 2 out. So I'll have this 1 by 2, 1 upon, now I'll have x square plus x by 2 minus 1 by 2. I hope you got this step. You are just taking 2 common out from all this. So it is this. Now what you do is, see, now coefficient of x here is half. So I'll have half, you divide half by 2, you get 1 by 4. You square this. So you square this, you get 1 by 16. So what I'll do is I'll write 1 by 2 integration dx, let's write dx upon x square plus x by 2. I'll add 1 by 16, I'll subtract 1 by 16 minus 1 by 2. This is the same thing which you used to do in school. So now you get a perfect square, which is x plus 1 by 4 the whole square and 1 by 16 minus 1 by 2. So this you can solve this part and see what you get. So what I'll do is I'll solve this separately. So what I'll do is I'll write minus common 1 by 16 plus 1 by 2. So what you get is, so 2 and 16, you take the LCM and you get this as, so this will be 3 by, so in fact what you get is you get 3 by 4 the whole square, right? Because denominator will be 16, here you will have 2 eights are 8 plus 1 is 9, so you get 3 squares. So what you get is, this is minus 3 by 4 the whole square. So now again you just have to relate this to the formula. So actually what is this? This is actually of the form, this is of the form integration dx x square minus a square, right? So now you just have to remember the formula. So the formula for this is 1 upon x square minus a square. So the formula was 1 by 2a log x minus a x plus a plus c. So this was the formula. So just apply this formula here. So what you get is 1 by 2 is outside. Now you have to write 1 by 2a. So 1 by 2. And what is a? 3 by 4. So 3 by 4 log of x minus, so x is this x plus 1 by 4, you're getting it. So this is x, right? This entire thing is x, right? So 1 by 4 minus 3 by 4 upon x plus 1 by 4 plus 3 by 4 plus c. And now you can just simplify this, and you can write the answer. You can cancel this 2, you can simplify and you can get the answer. So after doing some simplification, you will end up getting this answer. So the final answer will be 1 by 3, because see this 2 is 4, so this 4 gets cancelled, so you get 1 by 3 log. And now if you want, you can take LCM, and you can take LCM and you will get x minus half, and this is x plus 1. So no need to take LCM, you can just write this way, or you can take just LCM and you can solve this. So you got this answer, right? So hope you are getting these sums. Now let's take one question wherein you have square root. Let's take one of those questions. So let's say you have the question as the third one for today, that is integration dx upon square root, and now you have 3 plus 4x minus 4x square. So now this question. Now see, now coefficient of x is minus 4. Coefficient of x square is minus 4. So we can't have a minus 4 here. And obviously we can't take negative outside because this is square root. Okay. So what I'll do is, um, but I can take 4 out, right? I can take 4 out. If I take 4 out, I'll get 1 by 2. So I'll get 1 by 2 integration dx upon square root of, so 3 by 4, and this 4 is out, so this is x minus x square. I hope you got this step. Okay, once you have done this, now what we can do is, we have to get rid of that negative sign. So what I'll do is, I'll write this as, I don't need 3 by 4 yet, so I'll write 3 by 4 minus, I'll take minus out, so I'll get x square minus x. This is what I get, right? Okay, so I've taken minus out. Okay, now see, now what is the coefficient of x? The coefficient of x is minus 1, right? So minus 1 you divide by 2, you get minus 1 by 2. Obviously you square this and you get 1 by 4. Okay, so what you have to do is, now you have to add 1 by 4. Okay, and you have to obviously subtract 1 by 4. Okay, so now in next step, what you'll get, 1 by 2 integration dx upon square root of, now let's be very careful here, so 3 by 4 minus, now see, now this, we are interested in this part, so this is what, actually this is x plus 1, so this is x minus, this time it's minus, so this is x minus 1 by 2 the whole square. And see, this minus 1 by 4, minus into minus plus, so this is plus 1 by 4 outside. Okay, now this is 3 by 4 and 1 by 4 is 1, so what you get is 1 by 2 integration upon root of 1 minus x minus 1 by 2 the whole square. Okay, and now we get this in the perfect way which we wanted. So this is dx upon the root of a square minus x square. So this I can write obviously as, this I can write as this I can write as square, 1 square minus this. So this is the easiest formula which we had. This is actually sine inverse x by a. So 1 by 2 is outside. So sine inverse x is what? X minus half upon 1 plus c. And you got the answer. Okay, so it's very easy to remember this type. And the final answer, you can again write this as half sine inverse. You take the LCM. So you get 2x minus 1 upon 2 plus c. This is the answer, right? So just remember the step and just remember the type actually, dx upon. So numerator is 1 and denominator is quadratic equation, either inside the root or outside the root. The coefficient of x square can be negative and it can have a number. You just have to make sure that you take it common and you solve the sum. So hope you like this video, and till next time, take care. Bye bye.